Hey, welcome all. Welcome to part 4 of Writing Better Scala. First of all, thanks to the feedback that I got for the rest of the videos. They are in the description below. Please watch them if you haven't. And yeah, the purpose of this video series is to share the practical benefits of functional programming, the practical benefits of writing things in a language like Scala. And even if you're not using Scala at your workplace, some of the concepts that you learn from these videos could be useful. And I'm pretty sure it will be useful. Like a couple of years before, when I got so interested in functional programming, one of the things that I got really used to was recursion. And it has helped me a lot. You get to solve most of the problems using just recursion because you get so used to it that you do it on a day-to-day basis, and you get to solve even algorithmic problems using just recursion. Another thing that helped me a lot was the concept of pushing your business logic into the types. That improved my productivity. As a developer, we need to be really productive in terms of what we deliver. And whatever that we deliver should be reliable as well. So we don't want to catch those bugs at runtime. We need to catch those bugs at compile time. And we should also be writing property-based testing that will emit 100 test cases, and that might say, well, 98 is successful, but 2 of them is a failure. So you better handle those inputs as well. So these things really helped me as a programmer, regardless of the language that I use. Recently, I used Hypothesis in Python, which is a property-based testing that I use in Python. And that is something that I learned through Haskell and Scala. And then I adopted that to Python. It was not as ergonomic as I do in Scala, but something is better than nothing. Another package that I used in Python was OSLash, which is sort of a copy of either data type in Scala. So we have already seen the benefit of using either and the way we push the business logic to either. That said, Python is a language where you have limitations. Like, you may not be able to catch all of those bits at compile time. There is no real compiler in Python telling you that this is a wrong business logic, right? Unlike Scala. But anyway, it's still going to be beneficial. In this session, we will discuss 2 things, actually 3 things. One is how to customize the keys in your config. Second, how to customize your auto derivation. And the last bit is creating some examples of your config for the user. A quick recap. We had a data source, which is your source of your ETL framework, and that can be database, S3 bucket, or Kafka. And we auto-derived config descriptor. And then we gave a config. Now this is not going to work. So by default, you need to pass the type of your seal trait in here. So my source is of the type database. And if it is of the type database, you have to pass all of that values. That's a default behavior of zeoconfig. Right? Now we are going to go ahead and change some behavior of this config. And that behavior is the keys. Now, in some libraries, the keys are automatically mapped to a camel case or a kebab case corresponding to the field name in the case class. So for example, if it is bucket name, you have to then pass bucket name in your config. And that's sort of an assumption made by the library. zeoconfig doesn't make that assumption. You have to pass exactly the same name as that of the field name in the case class. But if you want to change it, you can simply change this descriptor, because this descriptor, end of the day, is a program, and that program has functions in it that can manipulate that program. So you pass that to uppercase. Now this is going to accept all the keys as an uppercase. So this, let's try source, database, password. Okay, source nested under database, host, port, username, password. Now that should work. Or well, region, although it is optional. Now that worked. One more change that we wanna do is, do we really need the name of this database as a parent node, or should that be part of your config itself? Like that. So let's go to the descriptor API doc. You can see a whole bunch of API doc out there. And in here, we have a configuration that is required. So we're going to use that. There are several reasons for why someone need this type of a configuration. There are libraries that makes use of this type of encoding in Scala. One of those libraries is pureconfig. I think I've mentioned that in the previous video. One of the great libraries out there that you can check out. So it's derived config descriptor. Now we have to import certain things here, which is descriptor.sealTrade strategy to bring about all of these things. So we are labeling the class name as type, and we ignore the SealTrade name. So we don't care what the name of the SealTrade itself, but we care about the subclass name. So this is labeled as type. Now let me get back to the previous version, which is source host port username, password, and type. And that's database. It reduces confusion. So we don't want to go too far with this. So we are going to map the name as it is. But this is custom derivation, but we are still using the old derivation. So we need to import custom derivation and then use, it's good to be really specific, so you can do this one as well. So custom derivation.descriptor. So now this is going to make use of this SealTrade strategy that we specified. Okay, now we are going to run this. So source, host, port, username, password, and that should work straight away. So that worked. So let me revert all of these bits, because it's a good idea not to use custom derivations and stick on to the default behavior, because that's going to be much more maintainable in your code base, and it's easy for me to explain as well. That username is not the same name as that of the field name, because we're using camel case. We don't need custom derivation, so we delete that bit. All right. The next thing is, well, we have encoded some of the logic, business logic, into the types, and then we are mapping the JSON config into your data types. But then while we encoded everything using types and we auto-derived things, now there is a difficult thing to solve, and that is, how do we tell this to user this is what we expect? How do we tell this to user? Do we need to hard code something and give it to the user, or update the Confluence page? And even if you give that, it may not have all the possible valid values, because it can also take the shape of S3 bucket or Kafka. And tomorrow you might incorporate more sources, more parameters, and it gets complex, and you really don't want to go ahead and change all of these bits manually. So we have a function in zeoconfig, specifically in this module called zeoconfig gen. So let's import that one. This is going to take a little bit of time. Going back to the main, this is our application config. Remember that this application.config is our descriptor. So descriptor knows about your application config, isn't it? So we pass the descriptor into another function called gen instead of read. Let's do that now. There is a gen function in zeoconfig, generate config. Actually, there is generate config JSON. and then you pass the application config descriptor, and then you can specify how many configs that you need to create, sample config that you need to create. Now that is an ZStream. For those who are not familiar with ZStream, don't worry. We can, for the time being, and only for demo purpose, we are going to unsafe run that bit into something that we know. So coconfig gen underscore. When you do that, this function will be available for you to use. That is unsafe run chunk, and that's going to expose a chunk. Consider that as a list, by the way. And that's not equal to list. It's got better performance. It is exposed by Zio, and this is going to give a chunk of 10 configs. Println result, a chunk of string. Let's see how this goes. Oh well, we gave Kafka and then we gave database details, and that's what it is complaining about. Pretty sure that's what it is complaining about. We fix that. It's taking time. Okay, yeah. Look at all possible values that this config can take. Super cool. Source can be a Kafka. If you're giving a Kafka, it should be a brokers, and that should be a list. You should give a topic name, and you can choose to skip region. So let's see if there is a source with Kafka along with region. There you go. Another config. This time the brokers have multiple values, and that has a topic name, and that has a region as well, which is optional. Or your config can be as simple as S3 bucket, pass a bucket name and prefix, or it can be S3 bucket along with region. So these are different possible values your config can take, and it's auto-generated by ZioConfig gen functionality. Now that's it for this video. Now we will be moving towards a whole lot of other possibilities with this config library in the next set of videos, and along with that we will be explaining the importance of type parameterization, the importance of, hey, let's don't use string, and so on and so forth. And we'll also explain documenting these types, documenting this config. We have explained generating some sample configs, but there is also another functionality called generate markdown documentation that explains each field, the business explanation of each field, which the users can refer to. But we'll explain that in the next session. I hope you enjoyed this video. If so, subscribe and give a thumbs up, and keep supporting me, and I'll come up with better topics and better ideas of programming in upcoming videos. Catch you all.